Hello there. My name is Rui Gutierrez. I'm one of the epidemiologists working for MSF Barcelona. Today I'm recording a series of videos in which I want to share with you how I do exploratory data analysis using Microsoft Excel. So if this is something you think you might be interested in, please follow along. There's a number of videos that I'm going to be recording today. And before we get started, I just want to share with you what do I mean by exploratory data analysis using Microsoft Excel. So please let me know if you have my screen. This is the title of the presentation. We're specifically going to be looking at line lists today. And we're only going to be using Microsoft Excel. We're not going to go into Stata. We're not going to go into R or any other software that you might not be familiar with. And let's just see some definitions. Well, what do we mean by exploratory data analysis? Here on Wikipedia, we have an actually really good explanation or a definition of exploratory data analysis, which is basically a way to summarize characteristics of data. Sometimes we're going to be using graphics and other data visualization methods. We're not going to be using models today. And what we're going to try to do is try to see what the data can tell us beyond the formal modeling. And I really like this image that they have here, which shows reality represented by the globe, from which data is collected, data is then processed, then there's the clean data set, and from there, exploratory data analysis. So what we're going to be doing today is cleaning up the data set and doing the exploratory data analysis. And more specifically, we're going to be using a real-life example. This is a line list that comes from Yemen. It was not collected by MSF. It was collected by a partner organization. It's data from 2018 all the way up to 2022 regarding cases of measles, suspected cases of measles. So the information was collected in this Excel spreadsheet, and we want to make some sense of this information. So how can we do that? Well, first thing we can say that there seems to be many variables. So when we talk about a line list, we mean that each line represents a patient and each column represents a variable. So we can see here that we have many variables. It goes from A all the way to X, okay? And we do have a lot of patients. Let's see, there are over 300 or 500, here we go, 700 patients. Actually, 700 is right on the spot. So how can we make some sense of this information? We know that there's a lot of information here, but just like the way it is presented here, it's really difficult to make any sense of what we have here today. So what I'm going to be showing you is how I would tackle this issue. I'm not saying this is the only way of doing it. I'm not saying this is the best way of doing it. This is the way I usually do it. And if you have something similar in your hands and you're a bit lost, you can follow along. If you already have your own process of doing it, you can maybe tag along and see some things that we might be doing differently and that can help you with. But by no means I'm saying this is the only way of doing it. I'm not even saying this is the best way of doing it. This is the way I do it and which I would really like to share with you. So if you look over here, we have the same information of the line list. You can see it's organized a little bit differently. I'm going to go through it, but usually we will not be looking into here, but rather into this other page, which I've created. We're still in Excel. And here we have the same information, but it's a little bit organized by a few graphics. So here we can see how many cases we had per week. What was the age category of the patient? So we had 23% of them were on this age category, is 2 months, 2 to 4 years. What was the outcome of the patients? So we had that 97% of them were cured, 3% of them deceased, and which district they came from. Up here, we have some filters, which you might be wanting to look at only specific parts of the data, so specific chunks. So let's suppose here we have a filter for the year. We only want to look at data from 2021. We can click here, and immediately all the graphics change to reflect the information only from 2021. You can see that the outcome, the case fatality rate seems to be a bit higher in this year. The seasonality of patients is a little bit different. We don't have that bulk of patients here in the beginning of the year. The areas where they came from also seem to be a little bit different. Or maybe we're interested in specific age categories. So maybe we're interested only in patients between 6 months and 2 years. We can select these three over here. And you can immediately see that we don't have any patients in this age group in 2018 or in 2020. And here is the distribution of these patients. You can see that the outcome is of 4% have deceased. The age category, of course, here has changed because it's only these 3 age categories we're looking at. And the district from which they come from has also changed. So this is something I'm going to be showing you how to do today, if you're interested in. And of course, you don't have to do exactly as I did. I'm just going to be handing you the tools that I did to use this or sharing them with you. But maybe, for example, this graphic over here, you know what? I don't really like this graphic for age category. There's a bit too much information. It's a bit difficult to read. You can just maybe change the kind of graphic. Maybe we prefer a column chart. Maybe it will be easier for us to read it as a column. So here, now we have the same information as columns. And of course, if you want to come down below here, you have the same information also in the tables, which generated these graphics. So these are pivot tables. Some of you might be familiar with them. In these pivot tables, you can do pretty much all the calculations you need. So here, for example, we had the age categories of the patients, which I was showing you before, but maybe you want to see the outcome by age category. So in this specific age category, it's less than 6 months, how many patients were cured, how many deceased, how many unknown or blank, and the grand total of patients. And of course, from here, you can start to make some calculations or comparisons. Perhaps you want to calculate the case fatality rate for this specific age group. You just get the number of deceased, you divide it by the total number of patients, and you get that the case fatality rate was of 3.39%. Maybe you want to compare it with a different age category. Let's see this one down here, 2 to 4 years. We do the same calculations. 4 patients deceased. Divided by a grand total of 155 patients. And we get that the case fatality rate was of 2.58%. Right? So if this is something you think you might be interested in, you want to follow along, please tag along. What we're going to be doing today, this is the outline of what we're going to be doing today. So there's an introductory part. I'm going to be talking a little bit about the language, specifically which language your Excel is set up in, data security, tables in Excel, how to remove duplicates. We're going to be talking about some basic Excel functions today. If I'm not mistaken, it's only 5 functions. They can be really helpful if you know how to merge them and use them together. Next, there's a part about how to do dates in Excel. So Excel sees dates in a very peculiar way. And if you want to calculate the difference between 2 dates, that might not be as easy as it seems. Finally, we're going to be doing the exploring and cleaning up of variables. Then the pivots. Finally, I'm going to teach you how I refresh data, which is not in this example so far, and how to save the data. So if you think this is something that could be interesting to you, that you want to follow along, please do. I'll be glad to share these tools with you. Okay, I'll see you in a bit. All right, so for the first part, actually, before we even get started in the analyzing of line lists using Excel, I want to share with you just something that it's important for you to be able to follow along, is that today I'm going to be using Excel in English. Even though you might have noticed that English is not my native language, but you can see that my Excel is all set up in English. And even if it's not your native language, I do recommend having Excel in English. The names of the functions are going to change depending on which language Excel is set up in, is installed in your computer. And if you want to follow along this presentation, you need to have it in English, or you can also Google how to translate the command that I'm going to be giving to you from English to whatever language that you're using. In case you want to change your language, what you do is that you go under File. Of course, in your case, it's not going to say File. You click here. All the way in the bottom, you have Options. So you select Options. And on Options, you have the option to here select Language. And this is how you change your languages. So English is the one which is installed in my computer right now. I could also have Portuguese because I'm from Brazil, or Spanish. And if you want to change, you just go ahead in this window here and you change the language. If you're using an MSF computer, you're going to need administrative passwords. So you're going to have to contact IT on how to change the language on your computer. Okay, I'll see you in a bit for the next part of the presentation. All right, then. So moving on to the presentation. One of the most important things we have to think about is data security. In this case, we have sensitive patient information. Any file which contains patient information must be password protected. This is a requirement from our organization. So every time you have patient information, you have to password protect your data. So how do we do that in Excel? Well, let's go back to our line list. Here's the information we have. You can see that I blacked out the name of the patient so that they're a little bit more protected in terms of confidentiality. But what we need to do is go under File. Here on the left column, we have Info. And here we have the option on how to protect the workbook. We click here and then we say encrypt with password. So it will require a password every time we want to open this workbook. You just click here. It's going to request a password. Typed in my password. It's going to ask me to repeat the password. Here we go. And finally, the workbook is now password protected. Okay. Another important thing to keep in mind is anytime we're going to share this file in an email. So perhaps I want to share this information with a colleague of mine, and we're going to send it in an email to this person. Never share the password in the same email as I'm sharing the file. So in separate emails. So I'll first send an email with the file, and then in a separate email, I'll send them the password. Never in the same email, the file and the password. So this is how you protect your workbook using a password in Excel. So continuing with our presentation, let me again share my screen with you. So now we have password protected our database. One of the things that I like to do when I'm working on some information like that is to copy everything. You can do that by coming in this little triangle between A and 1. If you click here, you're going to select all the information you have. I press Control C, I go on a new spreadsheet, and I press Control V. This way, if I make any kind of mistakes, I can just go back to the original information and continue with whatever it is that I was doing. Okay, let me go here to Home. On View, I'm going to zoom in a little bit so it's a bit easier for you to follow along, right? And the way I like to work with this kind of information in Excel is to convert everything into a table. You can do that either by going into Insert and clicking on Table over here, or you can just press Control T. And what happens is that this little window pops up, Create Table. It's going to guess the boundaries of your table. In this case, it's guessing correctly. And it's going to ask if your table has headers. And I will select this. It's important to know that it will only identify the first row as headers. Sometimes these information can be a bit grouped together. So for example, patient information, signs and symptoms, treatment, outcome. So it all needs to be boiled down to a single column, single row, excuse me. And once you click on OK, you're going to notice some differences. The first thing, the very obvious one, is the colors. So now it's a little bit easier to read. You have these different shades of blue and white, which make it a little bit more legible. Also, you might have noticed that way up here on the top, you have a new ribbon, which says Table Design. We didn't have that before. And in fact, if we go anywhere outside the table, so if we move here to select this cell, that ribbon has disappeared. We go into the table, the ribbon appears again. This gives us a few options. First, here on the right, we can select the colors of the table we want. If you prefer a specific one, you can choose. There are many options. I usually don't touch on this. You could also notice that here, you can give a name to your table. In this case, since these are measles cases, I'm just going to say measles. And it has a number of other options we're going to be exploring today, okay? One of them that I want to talk to you is the total row. You can select this total row here. And now you have a new row at the bottom of the table, which allows you to do, once you select a cell here, it gives you this drop-down menu over here, and you can just choose the average, for example, of a specific variable that you want. Or perhaps you want to see the sum or the count, for example, the case number, we want to see the count. 700 patients when we say this. Right now, I'm not going to be using it, so I'm not going to select it, but I do like to work in tables, and I'll show it to you in a bit. Thank you. Okay, so moving on, we have converted our information into a table, and now we want to check if there are any duplicates in our table, right? There are a few ways of doing this. Let me go to the table. So if you have the table selected here, on the table ribbon, you might see this little icon here, which says remove duplicates. If you click on it, another window will pop up. This has all the names of the columns, which are our variables, and you can select all of them. You can unselect or just a few of them. Usually I will not select all of them. I will just select the name and probably something related to the date in which the patient was seen or date of start of symptoms, or maybe just the admission date. And if there are any duplicates, it will remove. In this case, there are no duplicates. This is one way of going about this. I don't really like to do it like this, and I'll let you know why. If you do it like this, it will simply remove any duplicates that you have, and you have no further information on that duplicate. So maybe it was just somebody that had the same name as a different person, or maybe it was a patient that came once, it was feeling better, they went home, and then they went back to the same facility a couple of days later. It's a bit more tricky to do it like that. So one other way that I like to do it, let me just take you to another example here. So, and I'm going to show you how to do it in a different way. So here we have the name of the 4 Beatles, and I have repeated them here with slight differences. So in here, there's a difference in the spelling. In Paul McCartney names, there is no space between the first and the last name. George Harrison is only in lowercase letters, and Ringo Starr is all in uppercase. So if I select all of them, let me just put them all in the same column. I can select these cells, and of course, on the insert, actually on the data tab, you also have the remove duplicates possibility. So if you click here, it's column B, it will automatically remove the duplicates, right? And keep in mind that it did not identify John Lennon names as a duplicate nor Paul McCartney because of the small differences. So it will only not differentiate between lower and uppercase letterings. Any other slight mistakes, it will not identify as a duplicate. So this is a 100% match that Excel is looking for. But the way I actually like to look at this kind of information is that I will select the column for the name of the patients. And here on the Home tab, you have the conditional formatting option. And if you select the highlight cell rules, you can highlight the duplicate values. So in this case, now all the duplicates are in red, and I can see if they are true duplicates or not. Maybe it's just a variation, maybe it is really a duplicate, but I would prefer to do it like this before going ahead and deleting some of the information we have on our original database. In this case, we don't have any duplicates, so it's not a problem. And actually, just to preserve the names of the patients, I'm just going to go ahead and delete the name of the patients, because I will usually only use the name of patients to see if they're a duplicate or not. If I know that there are no duplicates, I'll just go ahead and delete this. Okay, I'll see you in a bit to move on with the next part of the presentation. Okay, continuing with the presentation, I want to talk with you a bit about functions in Microsoft Excel. So what are functions? These are predefined formulas which we can use to automate some of the calculations we might want to be doing. So perhaps we have something that we want to do repeatedly. We can use the equal sign to inform Excel that we want to do a function, and then Excel will carry out that function repeatedly. Some typical examples are the sum function or the average functions. Let me show you what I mean by them. So here we go back to our example table. And I just put here a few numbers from 1 to 5, and maybe I want to see what is the sum of them, right? So if I use the equal sign, I'm telling Excel that I want Excel to do something specific with the cell. I can just say 1 plus 2, and it will automatically display the number 3 because I put the equal cell beforehand. But if I delete the equal sign, it will not do that. It just displays 1 plus 2. So we have to use the equal sign to tell Excel that you want them to perform this calculation rather than actually just show you the numbers, right? You can also use specific functions such as sum. If you open parentheses, it will ask for the numbers you want to sum. You can select them in their cells over here, 1 to 5. You close parentheses, and it will give you the sum. Another one which is very usually, we use it a lot, is the average, which is equal average. Again, you open parentheses, you select the cells that you want, and it will give you the average of these 5 cells. Medium is one that I use a lot as well. Again, it would be a 3 in this case. Standard deviation. So it's just, and this is in case, let's call this a sample. You select the cells, close parentheses, and it gives you the standard deviation. So this is a bit how Excel functions work. I think almost everybody here must be familiar with them. We're going to be using a few functions, the if function, a few date functions, what else? The search and the isNumber function in a bit. But when we get to that, we'll get to that. Okay, I think I have you with me right now. So now let's talk a little bit about dates in Excel. So how does Excel sees dates? So here I have a table in which I have 5 people that I just made up. Here are their dates of birth, and I want to know their ages. Well, how can I do that? Well, it's a bit difficult. So one of the things that I want to show you is how Excel actually sees dates. So if we select the cell over here, which has the date, which is May 11th, 1982, you can see here on the home ribbon that this is recorded as a date. But if I put as generic information, it will just show a number, a very large number, 30,082. What is this number actually? So let me go back to a short date. This number is actually counting the number of days since day 1. If you just type in any cell the number 1, if you convert this to a date, you will see that it's January 1st, 00. And in this case, 00 actually means 1900, not 2000. So this is actually January 1st, 1900. So any date from that is counted as a number. So Excel sees dates as integer numbers. So when I say that May 11th, 1982, it's actually 30,082. These are the number of days since January 1st, 1900. Okay, so let me just delete this column. So if I want to calculate somebody's age, for example, today is, let me go back to putting this as a date format. Today is February 5th. So let me just write here, 2022, right? So if I want to calculate the date, I can just subtract from today this date of birth, right? So I'll use the equal sign. I'll select the cell that has today's date, which is C1, minus the date of birth of this person. And now I have that this person on this date is 14,515 days old. Okay. If I click here on the bottom right corner, I can just drag down the same formula, and you see you have some very bizarre numbers, right? Some negative numbers. So actually what you have to do when you come to the cell in which you did the calculations, we want to select the first cell and we want to fix it. So all the other calculations, this cell will not change. To do that, you just press F4 and the dollar sign will pop up here before the first letter and the first number. So now when I scroll down this formula, it has the same calculation. You see it's C1 minus B3. Here you have C1 minus B4. Here you have C1 minus B5, etc. So, okay, but this doesn't really help us very much now, does it? Knowing how many days old a person is not really helpful. So how can we tackle this information? Well, one thing we can do is that we can take this information that we have here and divide it by 365.25, which is the average number of days in a year. So now I know that this person is 39.73 days old, and so on, okay? Oh, excuse me, this is actually not 2022, 2023. So, all right, so I have somebody who's 40.73, 42.72 years old. It's a bit tricky as well, because usually you don't say I'm 24.09. And actually, if we use these numbers and we start rounding them, you can see that some of the dates, all of them which has more than 0.5 of them on the decimal houses, are going to be rounded up. So here we have somebody who's 40 is going to be turning into 41. This person is going to be turning into 43, 25. You can see that now all the dates, the ages have changed. So this is not ideal, but there is something else we can do, which is using a formula, which is the int formula. Int means integer, means it's only going to take the whole number. So if I select this cell over here, for example, and use the int, it's just going to say 40, and there's nothing after, no decimal places. So it's just how many whole years this person has, right? So this is one way of calculating people's age, and you don't actually need the decimals. which is great. Still not ideal. One thing that I like to do when I'm using, so for this calculation, for reaching the number 40 here, there were multiple steps. So first I did the subtraction, then I divided by 365, and then I used the int formula. What you can do is use only one column. To do that, let me go step by step. Maybe we go back to the cell over here, which I'm dividing the subtraction by 365. And what I can do is that I use the formula int beforehand. I open parentheses and I leave the calculation inside of it, right? So now directly on column D, I have the information that I want, right? So I can just scroll down and copy this. So I don't need this column here anymore. And I can go another step further to do that in the first column. So what I can do here is that I can use the int formula, select everything that's inside. I open another parenthesis to close the subtraction, divided by 365.25, close parenthesis, and now I have everything in one column, right? So what I did here is that you can see every parenthesis, I'm doing a step of the calculation, and this is called the nesting one formula inside the other, and it's something that we're going to be using quite a lot from now on. Okay, so this is how to calculate people's age in Excel. In the case of the example we're following, the measles line list from Yemen, patient's age was recorded, not their dates of birth. So here we have the patient's age in months, in days, this patient's in years. We're going to tackle that in a minute. But I do want to show you a different way of doing it. Excel actually has a formula which will already calculate this for you. It's the dated if formula. So dated if, you open parenthesis, you put on the smaller date, a comma to separate it, the larger date, another comma, and then between quotations, you put the unit that you want. In this case, is in years. So it will give you the same information, but there are some, I don't know why it's, I forgot to fix the first date. So excuse me, I have to actually fix. So this is pressing F4 again before I can scroll down and have the ages of the patients. So now the ages of the patients are calculated only using this formula dated if, all right? And maybe for pediatric patients, for example, we might be interested in their age in months. So instead of years, we just put an M, and now we have the ages of the patients in months. In this case, of course, they're a bit older, so we're not going to use them in months. We're going to use the dates in years, okay? Another interesting thing that we might want to look at is, for example, which epi week, because we usually record dates in line list in epi weeks. In the case of the line list that we're dealing with, it has already been calculated in epi weeks. You can see here, excuse me, the epi week which each of the patients has been seen. But let's suppose that we don't have the information. We have here the date of consultation, and we want to know which epi week this was. Well, there is no direct way of doing this in Excel. One thing that you can do is that you go to a calendar. In this case, you can see that all of them have been seen in 2021. And epi weeks start on the Sunday, and they always run from Sunday to the next Saturday. So you can see that the first epi week of that year was actually from, let me just check on my calendar here, from January 3rd to January 9th. So the first epi week starts on January 3rd, but actually I want to go to the week before that. So it's actually, if I click here, on the 27th of December of 2020. This was the last epi week of the previous year, and let me just show you why we're choosing the previous one. So January 3rd, 2021 starts the first epi week of that year. And what we're going to do is that we're going to be doing simple subtractions again, right? So I'll do step by step. We take this date, we subtract, excuse me, we start by the equal sign, the date of the consultation, we subtract the first epi week, and we have the number of days since the first epi week for these patients. Again, I forgot to fix that I want everything cell C9 fixed F4. So I have some wrong values here, right? And the next step would be to take that same number from before and divide it by 7. So here you can see that this patient was seen on week 36, this patient was seen on week 15, week 50, week 31. And again, we would use the integer formula to know which week that was, so that there's no rounding. The thing is, there is no epi week 0. It starts on epi week 1. So one thing you can do, it's actually when you do the subtraction here, the division, excuse me, you just put this in parentheses and add 1 to it. So this patient was actually seen on week 1. This patient was actually seen on week 37, etc. Another way to do it is, instead of calculating it from the first week of the year, epi week, you can start by the last epi week of the year. So instead of C9 here, I want to select C10. And now this was seen 7 days after the last epi week of the previous year. If you complete them, now you have everything, but you don't need the +1 anymore. You just do the simple division. This is how I would usually do. So this is how to tell Excel how to automatically calculate which epi week you're in. And of course, I always like to nest everything inside the same formula. So you use the integer formula. You do the subtraction in another parenthesis, divided by 7, close the parenthesis, and there you have it, the epi week in which each patient has been seen, right? So this has been epi week 37, 16, etc. Okay, I'm going to stop this part right now, and I'll see you back here in a minute. Okay, so we're continuing with the presentation. There's another formula I want to talk to you about, which is the if function. Excuse me, not formula, the function. It's an extremely useful function, the if function. It may look very simple at first, but there's a lot of things that you can do using this function. So it only requires 3 arguments: a logical condition, the output if the logical condition is met, and the output if the logical condition is not met. So let me go back to an example line sheet. So let me just put here maybe a number, any number, number 5. And now I'm going to be using the if function, equal sign if, open parenthesis. And then the logical test is this cell over here, the number that is appearing, is it larger than 6? Then I put a comma. And what do I want the output to be if the condition is met? Well, if it is, I want the number 1 to be showing. If it is not, I want 0 to be showing. All right. Now, as I have a 5, remember, our logical condition is asking if this number is bigger than 6, I have a 0. If I put a number which is bigger than 6, like 7, it automatically changes to a 1. If I put 3, 0. 6 continues to be 0 because 6 is not greater than 6. 20, it's bigger than 0. Okay, it seems simple enough. One other thing that we can do, maybe we want it to say something in writing, not have a number. So perhaps I want it to say yes if it is bigger than 6, or no if it is not bigger than 6. So I just put yes and no under quotations. You want to press enter. If the number is bigger than 6, it will say yes. If it's smaller than 6, it will say no. Okay, we can use this function a lot. Let me delete this. If we're, for example, we have the ages of some patients. So here I have 10 patients with their ages recorded in months. And I want to see which age category they belong to. And these are the 4 age categories which I want to use: 0 to 5, 6 to 11, 12 to 23 months, 24 to 6 to 59 months. So one way of doing it is by going step by step. So is it 0 to 5 months? And then I can use the if function. I'll put the equal sign here. All right, if, open parenthesis, I select the cell which has the patient's age, and I ask, is it bigger, or excuse me, smaller than 6 months? If yes, I want it to say 0 to 5 months. If no, I just want it to say 0. Okay, and 0 to 5 I put under quotation marks. 0 to 5 months under quotation marks, and I close the parenthesis. So now this patient has age between 0 and 5 months. If I pull down the formula, I can see that all the ones which don't have age 0 to 5, between 0 and 5 months, will say a 0. Then I go to the next age category, which is 6 to 11 months, and I do the same formula. If, open parenthesis, actually, for this patient, I already know its age category. So I'll go to the next one, and I ask the same question. I use the equal sign. If, open parenthesis, is the age of the patient smaller than 12 months? If yes, I wanted to say 6 to 11 months. If no, I want a 0, and then I close brackets. And I only apply this to the patients whose age group I don't know yet. So now I have the age group for another 3 patients. Let's go to the next one, which is 12 to 23 months. I'll do the same thing, only for the patients whose age category I don't know yet. If, open parenthesis, is the age smaller than, in this case, 24 months? If yes, it's going to say 12 to 23 months. If no, simply 0. Okay, there was a small mistake. So I copy the formula here. And no patient is in this age category. I go to the following one, which is 24 to 59 months. And I apply exactly the same formula. If, open parenthesis, is this age category smaller than 60? If so, the age is 24 to 59 months. If not, I want a 0, right? And it should be positive for all of them. Right? So now I know the age categories of all my patients. And of course, you don't need to say, is it bigger than anything here? Because you already asked the first question. So what we're doing is actually that we're going to be asking a sequence of questions about this specific variable here. And then we want a response related to it. But what we can do is that we can nest all of these functions together in the same one. So if I go back here to the first one, I'm asking if cell B3 is smaller than 6. If it is, I want it to say 0 to 5 months. If it is not, I want it to say to show a 0. But maybe instead of showing a 0, if it is not, I want it to open another if, to ask it another question. Well, it's not smaller than 6. In this case, is it, I select the cell again, smaller than 12? If so, I want the age category to be shown 6 to 11 months. If not, show a 0, right? And then I have to close parenthesis twice. So here I can have it for all my patients again, right? So now I don't need this column anymore. I can delete this column because this information is all together in a single column. Well, maybe I want to ask yet a third question. So I've asked if the age category, if the age of the patient was smaller than 6 months. If yes, this is the output I wanted. If no, I wanted to ask another question. Then I asked if I wanted it to be less than 12 months. If yes, it would be show me this output. If not, I wanted to ask yet a third question. Again, you do the if function again. You select the cell again, cell B3. You ask if the cell is smaller than 24. If so, you wanted to say that it's between 12 and 23 months. You close quotations. And if not, you ask yet a fourth question. If is this cell, in this case, smaller than 60 months? If so, you wanted to say 24 to 59 months. And if not, what do you want to show? You can put a 0 as just to show that there's an error. Okay, so now if I pull down this formula, I'll have the age categories of all my patients, and I don't need any other column. So this is how you're nesting one function, one if function inside another one. Actually, we're doing here 4 times because I have 4 age categories, for all of them. And suppose that in this case, I only use children 0 to 5, but I put here maybe a mistake that instead of 33, I put that the age of this patient is 320. I get a 0. You can also choose to put instead of a 0 an error function of some kind here. Okay, so this is the nested if command that you're going to be using a lot when you want to put patients inside specific categories. Let me just show you in what we did is to ask a number of questions. Here I've used different age categories for the PowerPoint presentation, but we're first asking, is it smaller than 5 years? If yes, I don't want to go any further. I just want the output. If no, then I want to ask yet another question. If yes, this is the output I want. If no, I just wanted to ask another question. Is it younger than 20? If yes, this is the output I want, and the formula ends here. If no, I want to ask yet another question. So this is called the nested if. Some versions of Excel can do this a little bit easier using the ifs function with an S at the end of it. It's not my case, probably not yours as well. So this is how you use the nested if function. I'm going to stop this part of the presentation here. The next part, I'm going to continue to talk a little bit more about the if function. I'll see you in a bit. Okay, so we're going to continue with the if function to talk about the if function a bit more. If we go back to the table of patients which we received from our colleagues in Yemen, we can see that the treatment of patients has been written all in a single column. So it has the names of the medications which patients received in only one column, which is very different from the way that the symptoms were recorded. For the symptoms, we have one column for each symptom, and then we have marked it if the patient presented with the symptom or not. For the treatment, all is in one column, and this is impossible to analyze. So maybe I want to separate patients who received amoxicillin from patients who received ceftriaxone or azithromycin. So how do we tackle this issue? Let me go back to our examples spreadsheet. So here I just copy and pasted a few of the examples we had. So this patient received ceftriaxone, paracetamol, and vitamin A. The same thing for this one. This one did not receive vitamin A. This one received amoxicillin instead of ceftriaxone. This one received tetracycline on top of the ceftriaxone, probably eye ointment. This one received amoxicil, which is amoxicillin, but it's written a bit differently. We have ceftriaxone, amoxicil again, ceftriaxone. So basically the antibiotics I'm seeing here are ceftriaxone, tetracycline, and amoxicillin. So what I want to do is having a column which will tell me if the patient receives ceftriaxone or not, and then another one for amoxa, and then another one for vitamin A, and so on. Well, how can we do that? Well, we can use a little bit of Excel functions to try to do that. So the first function we're going to use is the search function. And as the name implies, the search functions will look for something somewhere. What do I want the search function to look for? Well, I want it to look for the word ceft, S-C-E-F-T, which are the first letters of the word ceftriaxone, within this cell over here, right? Excuse me, I have to put ceft between quotation marks. And a number 1 pops up, and I'm just going to drag this down. And we see that for some cells we have the number 1, and for others we have just this value, which is, we don't know what it is yet. What does this number 1 mean? It's just saying that they have found the word that we were looking for, or the letters of which we were looking for, which is C-E-F-T in this order, and they found it in the first 4 letters of the cell, right? Maybe, for example, let me just show you what happens if we just take this out of here. If we delete the word from the cell, it becomes a name. Oh, excuse me. Right? The value here is not recognized. It had not found it. And if we paste it here at the end of it, instead of 1, it's showing us an 11. Right? So this is what the number actually means. What we're interested in this case, it's only to see if we have a number here or we have anything that is not a number. Because then we can use the next function, which is the isNumber, which, as the name implies, it only tells us if a selected cell is a number or not. So I can just select it here, and it says true if it is, and false if it is not. Right? Okay, so for all the patients who received ceftriaxone, I will have in this column here a true. For the patients who did not receive ceftriaxone, I'll have a false. And finally, I'm going to use the if function. If this cell here, excuse me, I forgot the equal sign. If, open parenthesis, my condition is that if this cell equals true, then I want it to say yes. Otherwise, I want it to say no. Okay, I close parenthesis, and here I have a yes because this patient did use ceftriaxone. I just scroll down with the formula, and I have yes or no if each patient has used ceftriaxone or not. Another thing, a lot of times I would rather use 1 and zeros. In this case, I'm just going to go with yes and no just to make it a little bit more clear. Now, of course, we have 3 steps. We can nest all of them into the same one. So what we're going to be doing is the if function is actually nested inside an is number. So we go back. So is number, right? And we can put the if before is number cell 2 equals to be true. Then I wanted to say yes. If not, I wanted to say no. Then I close parenthesis. And now I don't need this column anymore. I can delete it. I have everything in these 2 columns. And of course, I can go a step further and I can select all of this. Actually, I can come here to the next cell. I do the search. I put before the search the is number. Open parenthesis, the search to see if it had found. It's going to become again a true or false. And then I go here and I do the if function outside everything. If everything here equals to be true, I wanted to say yes. Otherwise, I wanted to say no. Right, so I have all the information I want in a single column. The patient received ceftriaxone, or if the patient did not receive ceftriaxone, let me delete this column because I don't need it anymore. And I can do the same thing for amoxicillin. Right, I can actually just copy the formula here. I'll paste it over here, and I'll only change the word ceft for amox. And you don't usually use the entire word, because if there are any spelling differences, it will not recognize it. In this case, there was a typing mistake over here. So this patient did not receive the amoxicillin. And here I can know all the patients which received or not received amoxicillin. I can do the same thing for vitamin A, paracetamol, or tetracycline, or any of the other ones we might want. So this is calling a wildcard if. I'm using the if function to find if a certain word is inside another column, and I'm converting this variable. This is actually called dummy variables, dummy, D-U-M-M-I, dummy variables, which are only telling me information about specific variables. So ceftriaxone, yes or no, amoxicillin, yes or no, vitamin A, yes or no, which is the way you want it if you want to analyze a database. Okay, I'll stop here now, and I'll see you guys again in a minute.